Hello students, welcome back to the class. So in today's class we'll continue with the trihydric alcohol, that is glycerol, its properties. Okay. So when it comes to the properties, we have both physical properties and the chemical properties. In physical property, the glycerol is a colorless, odorless, viscous fluid, and it is also hygroscopic liquid. So the hygroscopic is a nature of any compound to absorb moisture from the air, okay, or it shows its affinity towards the water molecule because it has three hydroxyl groups. It is hygroscopic in nature, and also it is sweet in taste, and you know that it is non-toxic in nature. And coming to its solubility, it is soluble in water and ethyl alcohol but is insoluble in ether. Then the high viscosity or the high boiling point of glycerol is due to the 3-hydroxyl group, which forms a strong hydrogen bonding. So this is about the physical properties. Now let us know its chemical properties. This is a glycerol structure, which is nothing but propane 1,2,3 triol, and these carbon atoms, the 3 carbon atoms which are linked to 3 hydroxyl groups, are named as alpha, beta and alpha prime. This is an alpha carbon. Alpha carbon is actually a primary alcoholic group. Alpha carbon of this glycerol contains primary alcoholic group. This is because if you remember primary, secondary and tertiary alcohols, primary alcohol is a one in which the hydroxyl group containing carbon is linked to only one more carbon. Okay, if the hydroxyl group linked to carbon contains two carbons, then it is secondary carbon. Okay, so this CH2OH group is a primary alcoholic group, and this carbon is called as alpha carbon. Okay, then the CHOH of this glycerol, so this is the secondary alcoholic group, and this carbon is called as beta carbon. This is a secondary alcoholic group because the hydroxyl group containing carbon is linked to two other carbon atoms. Hence it is a secondary carbon, and this alcohol is called as secondary alcohol, and the carbon is named as beta carbon. Then coming to this third, again this is CH2OH, just like this alpha carbon. So hence this is alpha prime, and in some textbooks they also refer to it as alpha prime, just to differentiate it from this alpha, but otherwise it is the same group, CH2OH. So this is again a primary alcoholic group because the hydroxyl group bearing carbon atom contains only one carbon atom linked to it. Hence it is a primary carbon, and the alcohol is called as primary alcoholic group. Okay, so this glycerol has two primary alcoholic group and one secondary alcoholic group present in it. And generally these primary alcoholic groups are more reactive than the secondary alcoholic group, and this glycerol primary alcoholic group is more reactive than the secondary alcoholic group. Now let us know some of the chemical properties of this glycerol, where glycerol reaction with concentrated HNO3, a concentrated nitric acid. Glycerol react with concentrated nitric acid in presence of concentrated sulfuric acid, forming glycerol trinitrate. So here you can see the OH group. So in the OH group, all the H has been removed, and what is remaining is CH2O, CHO, CH2O, right? And to that, which group is getting added? To that, NO2 is getting added. So NO2 to the first, second and to the third carbon. Hence it becomes CH2ONO2, CHONO2 and CH2ONO2. This is nothing but trinitrate. So glycerol trinitrate will be formed. When glycerol reacts with concentrated nitric acid in presence of concentrated sulfuric acid, it forms glycerol trinitrate. And what is this glycerol trinitrate? The other name for this is nitroglycerin. Glycerol trinitrate is nothing but nitroglycerin, which is an yellow, oily, poisonous liquid, and it explodes violently when heated rapidly, which means this nitroglycerin or the glycerol trinitrate is an explosive. Okay, so the glycerol with concentrated nitric acid in presence of concentrated sulfuric acid forms an explosive called glycerol trinitrate or nitroglycerin. Then the next reaction, let us see, that is action of oxalic acid. In fact, with oxalic acid, different products are formed under different conditions. So what are the conditions? That is, temperature is a condition here. At 110 degrees Celsius and with excess of oxalic acid, this glycerol forms formic acid. At 110 degrees Celsius, glycerol forms formic acid, okay, when it reacts with oxalic acid. So let's see the reaction. This is glycerol, 1, 2, 3 propane, 1, 2, 3 triol. You are adding excess of oxalic acid and the temperature here is 110 degrees Celsius. Okay, so this is a condition here. So at 110 degrees Celsius only, the glycerol with the oxalic acid forms formic acid. Fine. So when it is heated with oxalic acid at 110 degrees Celsius, it forms glycerol monooxalate. So only one molecule of oxalic acid is added. Hence it is called glycerol monooxalate. And further, the decarboxylation of this glycerol monooxalate forms glycerol monoformate. So on removal of a CO2, it is forming glycerol monoformate. Okay, and this further undergoes hydrolysis, forming formic acid, and glycerol is regenerated. So this is how oxalic acid reaction with glycerol forms formic acid. Let me repeat once again. Glycerol with oxalic acid, when it is heated at 110 degrees Celsius, forms glycerol monooxalate, and this on decarboxylation forms glycerol monoformate, which undergoes further hydrolysis reaction wherein it forms a formic acid and regenerates the glycerol molecule. Okay. Whereas at 260 degrees Celsius, the same glycerol with oxalic acid forms allyl alcohol. So in the previous reaction you saw that at 110 degrees Celsius, glycerol reacts with excess of oxalic acid forming formic acid, right? Whereas at 260 degrees Celsius, glycerol when it reacts with oxalic acid, it forms allyl alcohol. So glycerol reaction with oxalic acid at 260 degrees Celsius forms glycerol dioxalate. This and further decarboxylation forms allyl alcohol. Okay, so at two different temperatures, two different conditions, this glycerol reacts with oxalic acid forming different products. Then action of hydrogen iodide on glycerol. Here again, glycerol reacts with hydrogen iodide in two ways. That is, in the first step, when glycerol is warmed or heated with a small amount of hydrogen iodide or HI, it forms allyl iodide. So glycerol, when heated with small amount of hydrogen iodide, it forms allyl iodide. Here, unlike the previous reaction that was with oxalic acid where temperature was a criteria, that with two different temperatures, two products it forms. Whereas here it is the amount of this reactant, hydrogen iodide. With small amount of hydrogen iodide, it forms allyl iodide. Okay, so the glycerol reaction with hydrogen iodide forms an unstable compound, and this on losing a molecule of iodine forms allyl iodide. Okay, so this is how glycerol reacts with a small amount. Now let us see. So what happens when glycerol is heated with excess of hydrogen iodide? So the allyl iodide, what is formed in the first step, that is with small amount of hydrogen iodide, with excess of hydrogen iodide, it is converted to 2-iodopropane. So with small amount it forms allyl iodide, whereas with excess of hydrogen iodide it forms 2-iodopropane. So this is the reaction wherein you know that till allyl iodide what is the reaction? That is with hydrogen iodide, when glycerol is heated, it forms an unstable compound which is nothing but 1,2,3-triiodopropane. Because it is unstable, it loses a molecule of iodine and thus forming allyl iodide. So this reaction takes place when there is a small amount of hydrogen iodide. Now, when there is excess of hydrogen iodide, the reaction further continues, wherein allyl iodide takes up some more amount of hydrogen iodide, forming another unstable compound which further loses a molecule of iodine, forming propene. Okay, now this propene again reacts with some more amount of hydrogen iodide, forming 2-iodopropane. Okay, so this is how the glycerol, when heated with excess of hydrogen iodide, forms 2-iodopropane, whereas with small amount of hydrogen iodide it forms allyl iodide. So this was about the properties of glycerol, wherein I hope you know about the physical properties of glycerol as well as some of the chemical properties of glycerol also. Okay, so thank you.